Rishita, am I audible?
Yes, sir.
Okay. I'll just wait for 5 minutes. So, today what we were going to discuss, I told you to prepare that, right?
Yes, sir.
Atomic structure, basically. Just wait a minute. Atomic structure. Abdullah. Today our class is for 1.5 hours. You already know that, right?
Yes, sir.
Okay. So I'm going to give you a very easy question, and that is calculate number of electrons, protons, and neutrons in following. First one is and also atomic number and atomic number. In all of this, you need to calculate number of electrons, protons, and neutrons.
Done, sir.
Done, everyone. So see how easy it is. This this is representation of element. This is your atomic number and this is your mass number. This is your mass number. And always remember this atomic number will be equal to always proton and it will be equal to electron only if it is neutral. If it is neutral. So proton atomic number will be equal to proton, which will be equal to electron, and that is equal to 11. Simple. In order to calculate neutrons, everyone knows that mass number is equal to neutron plus proton, and that will be equal to mass number is 23. And we need to calculate neutron. What is the number of proton or atomic number you can take? That is 11. So number of neutron is 23. Okay. For this, I'm going to write Z is equal to P, which will be equal to 11. But here electron, as I told you, electron will be equal to atomic number or proton only in case of neutral. And since plus is there, that means it lost one electron. So how many electron left? 10. And if you want to calculate number of neutron, you can write A minus P or A minus Z you can write. So C is A is what? That is written 23 and minus 11 that is equal to 12. Simple. Oh, wait a minute. I did it mistake. 23 minus 11 that is equal to 12. Right? 12. Now for this Z is equal to proton that will be equal to 13 and electron is equal to electron is equal to proton or atomic number only in case of neutral atom. And here it is not neutral. Plus 3, that means it lost 3 electron. It should be 13, but it lost 3 electron. Now it has 10 electron. In order to calculate number of neutron, A minus P or Z. So A is 27 minus 13. That will be equal to how much? 14, right? Now here you can see Z is equal to P. That will be equal to 16. Z is equal to P. That is equal to 16. And electron here, you can see it should be 16, but minus 2 is there. That means it gained 2 electrons. So it will be 18. And here A will be equal to, you can see 32. In order to calculate number of neutron, A minus P or A minus Z. I'm writing both because they are equal. So mass number is 32 minus Z, that is equal to 16. Is that all correct for you, Rishita, Abdullah, Siddika, you just Akib and Yasir?
Yes, sir.
Very good. Now I'm going to give you a question from NCRT. We will start from very basic NCRT. If you have revised the topic that I told you, then it will be very easy for you. Please do this.
Finish, sir.
What is the answer? Oh,
I
very
got
easy it is.
electron 35,
Very good.
neutron 45,
Very good.
and then atomic number.
35.
Yeah,
Very good. So everyone knows that this is your atomic number, right? It will be always equal to proton. And if it is neutral, then it will be equal to electron and all will be equal to 35. Now, in order to calculate neutron, A minus P or A minus Z, you can say A is 80 minus 35. That is equal to what? 45, right? Very good. Again, a question, very easy question from NCERT. Everyone knows the Planck quantum theory, right? We will come to that. These are some easy questions, and we should go through this first. Very easy it is. Any answer?
Yes, sir.
Yeah, number of electron, protons, and neutron in a species. This is your electron. This is your proton, and this is your 16. That means proton 16 means it will be equal to the atomic number. And representation of element we did like this. This is your atomic number. This is either sometimes it will be written like this on the left hand side, or it will be on the right hand side. Okay. Now you can see that this is your Z atomic number. So Z, that is equal to proton.
No.
So proton will be equal to 16. Atomic number 16. Assign the proper symbol of the species. So we can say that this is your 16, and mass. In order to calculate mass, you know that A is equal to N plus Z or N plus P. You can say 16 plus 16. This is the value given. So it will be 32. So here you are going to 32, write 32. And you can see that the electron is 18. That means it gained 2 electron. That's why there will be mass minus 2 there. Right, everyone? Was that clear? Rishita, are you done with this? Abdullah, Akib,
sir.
yes, sir. Siddhika. Okay. Now, the next question, I'm just going to ask you a theoretical question. Can anyone tell me what is the range of visible range? Basically, in this range, we are able to see, or out of this range, below range, and below or above, we cannot see. So everyone knows that it is 400 nanometer to 750 nanometer. If any object having this much wavelength, then we are able to see that, or else we will not be able to see that. Basically, this is the part of wave in which electromagnetic waves form. If you have seen in NCRT, you have seen there is alpha ray, sorry, ultraviolet rays, microwaves, radio waves, cosmic rays, lots of other rays are there. Is that clear?
Yes, sir.
Okay. If you're not getting my point, you can ask me. I'll tell you again. Okay, very easy question. I'm going to again start from this topic, then we will go on QIQs of NEET from this topic as well. So this is the question. Please do it. Any answer, any one of you? Any answer?
No, sir.
No. Are you not able to solve this? Yes or no? See, Vivid Bharati station of All India Radio Tele broadcast on a frequency of this much. That means frequency is your 1368 kilohertz. Calculate the wavelength. We need to calculate wavelength lambda of the electromagnetic radiation emitted by transmitter. Which part of the electromagnetic spectrum does it belong? So you have to remember some of the what we say. I will tell you how to remember these things. Okay. So what you need to do, lambda you need to calculate. There is a relation nu is equal to c by lambda. Have you studied this?
Yes, sir.
So c is what? C is your speed of light. C is what? Speed of light. And the speed of light is basically 3 into 10 raised to the power 8 meter per second. You need to calculate lambda, so I can modify this formula in this form. Now c is 3 into 10 raised to the power 8 meter per second. And this is in your kilohertz. So what we need to do, we are going to change this into hertz. So we are going to multiply it by this. Now just hertz is what? Hertz is basically per second as well. So this hertz is, you can write per second as well, and this will be cancelled. And then you can calculate it. It will come out to be 291.2 meter. So the lambda is 291.2 meters. And now from where it belongs, so we will talk about this. Basically, it belongs from what we say radio waves. I'll show you, and I'll show you a trick how you are going to remember it. Let me know when you are done with this.
Yes, sir.
Rishita.
Yes, sir.
So this is what you need to remember. Very important it is. I took it from NCRT. And how you are going to remember this gamma rays, X-rays, cosmic rays. This is X-rays, ultraviolet, infrared, microwaves, and there comes your radio waves. Okay. Sorry. Yes, radio waves, FM and AM, and then long radio waves. How you are going to remember it? Since we got 291 point something meter, that comes 10 raised to the power 2. And you can see, so it comes under this 291.2 meters, something like this. Now, how you are going to remember this? There is a shortcut which you can use. Now, I'm going to write a sentence about this. College girls are ultimate visitors in my restaurant. Now, since I don't owe any restaurant, so this statement is false, so I'm going to cut it. Now, C is for cosmic, G for gamma, X, here it becomes X, so this is your X-rays. U is for ultraviolet, V is for visible. Visible, you need to remember this, visible lies from 400 to 750 nanometers. I is for infrared, M is for microwave, and here R is for radio waves. They can ask you the increasing and decreasing order of wavelength and frequency. And as I told you that nu is equal to C by lambda. So you can see frequency is inversely proportional to wavelength. So as you can see, when you are going to move from left to right towards radio waves, can you tell me Vibgyor you have studied, right? Vibgyor
Yes, sir.
in class 10th. Which one will have the longest wavelength, maximum wavelength? Which one will have? Violet, indigo. Out of this, the maximum wavelength will have ray of red, yes or no?
Red.
Right. So in this way, you can connect this. This R is red and this R is radio waves. When you are going to move from left to right, lambda will increase. That means wavelength will increase. And since frequency is inversely proportional to lambda, so frequency here will decrease. So with the help of this sentence, there have been twice or thrice questions has been asked. Which one of the following order is correct? Either they will give you to arrange in for frequency or for wavelength. So if you know this sentence, you can easily arrange all this. Cosmic has the maximum maximum frequency. That means lowest wave, maximum frequency. So lowest wavelength. So when you are going to move from left to right, wavelength increases, and wavelength increases. That means frequency decreases. This statement is very important. You can write it. Let me know when you are done with
Finished, sir.
Any answer? Oh, wait a minute. Let me. The question says that the wavelength range of visible spectrum extends from 400 nanometer to red. This is your violet and this is your red. 750 nanometer. Express these wavelengths in frequencies. Rishita and
Sir, I'm still doing.
okay, please do it. I'm waiting. Abdullah, any answer? Rishita, still you are calculating?
Yes, sir.
Okay, I'm going to show you. It's very easy. Now, you should not take this much time, all of you. In order to calculate wavelength, express this wavelength in frequency. Nu is equal to what? C by lambda. C is what? I already told you. 3 into 10 raised to the power 8 meter per second. And lambda is given in nanometer. And since it is in meter per second, so you are going to convert this into meters. Okay. Okay. Now see what you need to do. Just solve this. You will get it. 3 into 10 raised to the power 8. Meter will be cancelled by meter. Upon, you can see this two zeros will be cancelled by 10 raised to the power minus 9. So it will be 10 raised to the power minus 7. Now what you need to do, 3 by 4 into 10 raised to the power, when it will go up, it will be in positive and it will be 10 raised to the power 15 per second, something like this. Yes or no? And when you are going to solve it, what you will get is 0.47 jet 28, 45 jet 25, right? Yes or no? When you are going to solve it, 47 jet 28 into 10 raised to the power 15 per second. And you can write 7.5 into 10 raised to the power. What it will be, positive or negative? 14 per second or hertz, you can write. Everyone got it, yes or no? In the same way, you need to do the next one. Next one is also very easy. Nu is equal to c by lambda. C is the speed of light, that is 3 into 10 raised to the power meter per second. Upon what is the wavelength? 750 nanometer. That means 10 raised to the power minus 9. You are going to multiply it. Again, 1 0 will be cancelled with this. So what we will have 3 upon 75. And here it is 10 raised to the power 8. And here it becomes into 10 raised to the power minus 8. When you are going to divide it, basically when it will go up, it will be positive, and this will be cancelled by 25 times. So this will be 1 by 25 into 10 raised to the power 16. And when you are going to divide it, you will get 0.01, right? Sorry, 0.04 into 10 raised to the power 16. Or you can write 4 into 10 raised to the power 14 hertz. Yes or no, everyone? So in terms of frequency, the range will be 7.5 into 10 raised to the power 15, or you can write this basically 4 into 10 raised to the power 14 to 7.5 into 10 raised to the power 14. Let me know if you have any doubt in this. This was very easy. You should have solved it. Let me know when you are done with this. Oh, let me know when you are done with this. Any answer? Everyone done with this?
Yes, sir.
Let me know whenever you are done with that question or anything. Let me know when you are done with this. Rishita, any answer? Calculate wave number. Wave number has a direct formula. Very simple. You can tell me in the fraction. No need to solve it like in decimal. You just need to do this. Wave number has a relation with wavelength, which is inversely proportional to wavelength. So you just need to do this. Wave number is 5800 angstrom. Just convert this into meter, because you know that 1 nanometer is equal to 10 raised to the power minus 9 meter, and 1 angstrom is equal to 10 raised to the power minus 10 meter. And you can, the rest you can see 58 into 10 raised to the power 8, we can say. And this is your per meter, because meter is here, so it becomes per meter. Yes, very good. So you will get finally 1 upon 58. This is your 58 into 10 raised to the power. This is your minus, so it becomes positive per meter. And in order to calculate frequency, you know, C nu is equal to C by lambda. You can directly apply 3 into 10 raised to the power 8 upon lambda is what? 5800 angstrom. 5800 into 10 raised to the power minus 10. This is how you can do this. Isn't it easy? No one is replying. No one wants to do calculation, right? Yasir, Abdullah, am I audible to all of you?
Yes, sir.
Okay. Now I'm going to give you some questions. Now this, which is very easy. Basically, this question is also related to your, what do we say? Planck's quantum theory, basically. Planck's quantum theory, you know, right? Everyone knows that. What is Planck's quantum theory? Yes or no?
Yes, sir.
Okay. So, see, this is your question. Very easy it is. Any answer, Rishita? Abdullah? Siddika. Very good, Siddika. Rishita, what about you?
Sir, I'm doing it.
Okay, please do it. Sorry, I got disconnected. Am I audible to all of you? Hmm. So you can see wavelength is given, so we can use this formula directly. E, we need to calculate energy. H has a value 6.6 into 10 raised to the power minus 34, that is given. Into C has a value 3 into 10 raised to the power 8 divided by lambda has a value 45 nanometer, and you can convert this into meter. When you will solve it, you will get 4.42 into 10 raised to the power minus 18 joule. So please be careful about the unit or the question. Very easy based upon only the formulas. I'm going to give you another question. Any answer, any one of you? Very good, Rishita. Abdullah, Siddiqa, and Yasir. Anyone answer for question number this? So I'm going to explain. According to the law of photochemical equivalence, energy absorbed. You know that E is equal to H nu, which is equal to Hc upon lambda, right? So it's very simple. H is given as you just need to put the value and get the answer. H is what? 6.62 into 10 raised to the power minus 27, and it is in Earth. Okay. And after this, you can see this is your C, which is also in Earth. That means CGS unit. So we are going to take this as CGS unit as well. And now you can see equivalence. That means per mole we need to calculate for 1 mole. For 1 mole we need to calculate. So Na is given. So you are going to multiply it by Na to calculate in 1 mole, and lambda not given, so you are going to take it as lambda because in option in terms of lambda is given. So you just need to solve it and get the answer. Minus 27 is there, plus 10 and 23, it becomes 33. And when it becomes 33, right, 33 minus 27, what it will be? 3 plus 3, 6 only, 6. 10 raised to the power plus 6. Now you are going to multiply this numbers, which is very easy. 6.62 into 3 into 6.02, which will give you 119.55 upon lambda. And we can write it as 1.1955 or 1.196 into 10 raised to the power. Since I moved this decimal to 2 or 2 digits, so it will be increased by 2 and lambda. So this is the energy, law of energy equivalence. Isn't it easy? Abdullah, Yasir, why are you not responding? Am I audible to all of you, Rishita?
Yes, sir.
Okay. Let me know when you are done with this. Siddhika, are you there? Siddhika is not there. Yasir and Muhammad. Muhammad Yasir done, but Abdullah not responding at all. Okay, please do this now. Let me know when you are done with this. Any answer, Rishita? Yes or no?
No, sir.
No. Okay, I'm going to explain. Planck's quantum contains this. Planck's constant basically given. The speed of light is nanometer per second. Which value is closest to the wavelength in nanometer of a quantum of light of frequency? This very simple. You are going to calculate wavelength. You know that nu is equal to c by lambda, right? You need to calculate what? We need to calculate frequency, right? So c is already in nanometer per second. C is already in nanometer per second. So we are going to write 3 into 10 raised to the power 17 nanometer per second divided by lambda. Lambda is also given. Oh, wait a minute. Okay. Which value is closest to wavelength? Okay, we need to calculate wavelength. So what I'm going to do, lambda will be equal to c by nu. So this is your c, and nu in second I'm going to put the value. You just need to put the value of c. 6 nu 6 into 10 raised to the power 15 per second. Now this second and this second will be cancelled. Now the answer that you will get will be in nanometer, closest to this. So you can see 3 2 just 6, it will be 1 by 2 into 10 raised to the power. When it will go up, it will be in negative, and 2 will 17 minus 15, that is 2. So when you are going to solve it, it will be 0.5 into 2, that means 100. So answer will be 50 nanometer. Very simple it is, isn't it simple? This value h was given to distract you. Is that clear? In the
Yes, sir.
next class, what you are going to do, PPE, that is photoelectric effect and all, Bose and all, you are going to do. We're going to do a lot of questions. Bose model, very important. Bose model, that means basically radius of nth orbit, velocity of nth orbit, is and everything about Bose. Till from yesterday's previous topics and this up to this topic. Okay. Before quantum number, up to before quantum number, like you have de Broglie as well as de Broglie wavelength, then Heisenberg uncertainty principle. This all you are going to do. Is that clear? Abdullah, Rishita, Yasir.
Yes, sir.
This is it for today. I'll see you in the next class. Okay.
Bye, sir.
Okay. Thank you. Yeah.